stoichiometry, mass-to-mass relationships. Okay, this is going to be a little bit tricky, but I think we can do it. We're going to do number 5 together, because I believe that one is the hardest problem. I'm going to zoom in and head our way. Number 5. Alright, so remember our sandwiches. This is saying that we need 4 pieces of bread, we need 3 slices of cheese to make 2 sandwiches. Okay, these are our moles. They're also our coefficients. Those are the same thing. This is our ratio. For every 4 irons, we're going to need 3 of our diatomic oxygens to make 2 products, iron oxides. Okay. Now at the same time, we're going to go from mass to mass. We are going to begin with 5 kilograms of iron, and it says directions tell us to find the underlying substance. We want to know the mass of this. The reason we change it to moles is so that we can have our ratios. The moles tell us how much we're going to make. The reason we can't just weigh it out is because different items, like iron or oxygen or iron oxide, all have different weights. Okay? So as always, you're going to need a lot of colors. I want you guys to follow along the same steps that I do. So first thing we're starting with is what do we begin with? Begin with 5 kilograms of iron. Okay? And as always, we haven't used kilograms in a while. We're going to change this to grams like every other problem. So this first step you don't have to do because everything else is in grams like we always use. We should remember kilo, deca, deci, base units, centi, milli, which means we're moving our decimal over 3 spots. Okay? So this is the same thing as 5,000 grams. I want you guys to write that there. We're going to put a lot of stuff in here, so make sure you do it just like I do. Okay? That's our starting number. Okay? And let's put it over here. So all the way to the left, make sure you have lots of room. This is the important part, labeling everything. We have 5,000 grams of iron. Okay, so we have that many grams of iron. You have to label what it is. We're going to have different masses and a whole bunch of different stuff. We're going to do our first box. As always, we want that to cancel out. So we're going to need grams of iron down here, which means we need to look it up on our periodic table. Write this down. Periodic table. This is our molar mass. Iron, 55.847. Round to 1 decimal as always, 55.8. Okay? 55.8 grams of iron. That's what molar mass is, grams of whatever substance you're using. Okay? This is the mass. That's our molar mass. This is what 1 mole of iron weighs. Okay. So now if we stop here, this is going to tell us how many moles of iron we have. And then we're all done. Okay? But we don't want to know how many moles of iron we have. We want to know how many moles of iron oxide we're going to make. Okay? So we've already done this step a gazillion times. And as we can see, grab a different color. I'm going to use pink right now. Nah, I'm going to use orange. That crosses out with this. If I stopped here, I would know how many moles of iron I'm making. Okay? So this is we're just going to call this step 1. Step 2. It's going to be 1 box over. We want to change it to a different substance. This is where our ratios come into play. Okay? So we're looking at our iron, and then we also have our iron oxide. These are the 2 numbers we're doing, okay? Because we began with 5 kilograms of iron. If we began with oxygen, we'd be using this 3, but that's not what we're using right now. Okay? So, make your next box. Okay? Same thing. Whatever you last ended up with, that's what we need to have canceled out. We know down here, we're going to have moles of iron. Okay? Now, how many moles? This is where we look at our equation. Right there. We want 4 moles of iron. Okay? And we're going to highlight that. We got this number from whatever we started with. Okay? And we know it's there because we want it to cancel out. We know we want 4 moles of iron for every 2 moles of iron oxide. okay? Because that's what's underlined. That's what we want to change it to. So 2 moles of Fe2O3, okay? Same thing, I want you guys to grab a different color, highlight on here, okay? This is what we're going to. So when you do these other 4 problems, they're all going to look like this. Down at the bottom is whatever you're starting with, whatever they began with. And whatever we're going to is going to be highlighted in a different color, both in your equation and also here. This is your ratio. Now, so let's go back. Step 1, changing it to moles. Moles of your reactant. Step 2, okay? Now we're changing it to moles of our product. Okay? So then if we go back, moles of iron cancels out with our moles of iron down here. If we take 5,000, multiply it by 1, divide by 55.8, multiply by 2, and divide by 4, I realize that's a lot of steps, we then would have the amount of moles of iron oxide that we produce. Okay? We're going one more step. We're going from mass to mass. So now what we're going to do is we're going to figure out the molar mass of iron oxide, which we've done 1,000 times. We're just adding it to this last step. So draw another set of boxes. And we know that down here, you want, and I should write here, moles. We want what is 1 mole of iron oxide. Okay, kind of ran out. Oh, that should be a small 2. 1 mole of Fe2O3. Okay, where are we getting this? We're getting it from our periodic table. Molar mass. Okay, we should be pretty good at this point. So let's take a look. Iron we know is 55.8. Grab our calculator. 55.8 times dose is that, and we're going to add 3 16s, plus 16, plus 16, plus 16, or 16 times 3. Our molar mass for this of iron oxide is 159.6 grams of Fe2O3. Should have not made this last line here. Okay? Let's zoom in a little bit. Okay? Same thing, if we take a look here, moles of iron oxide, let's go back to orange, crosses out with our moles of iron oxide down here, and we're left with grams of iron oxide. We've now gone from our mass of our original substance all the way through. Okay? So we follow this through, 5,000 divided by 55.8, our molar mass, which we got from the periodic table. Multiply by 2, divide by 4, multiply by 159.6, and divide by 1. That's going to get us our answer. So let's plug this in, probably 2 or 3 times, because you have a lot of numbers here. 5,000 divided by 55.8 equals, do every step one at a time. Okay? Then we're going to multiply by 2, times by 2, divide by 4, and then multiply by 159, times it by 159.6, and that gets us 7,150.5. That is the same answer that I got last time. I actually already plugged this in a few times. Okay, so my answer, 7,150.5 grams of iron oxide. Remember, we're looking for whatever is underlined, Fe2O3. Okay. Now, right now, this has 1, 2, 3, 4, 5 significant digits. You're required to have at least 3. So I'm going to change this. I'm going to change this back to kilograms. So 1, 2, 3. In kilograms, my answer would be 7.15. My 0, you always round. My 0 says to stay the same. That is rounding. So 7.15 kilograms of iron oxide. You guys don't have to do this last step for the other ones because it's already in grams. I'm just changing it. You have to have at least 3 sig figs. If you end up with 4 or 5, that is okay. I'm going to put a box around my answer, and I'm all done. I'm going to zoom out so you guys can kind of see this. This is what every problem should look like. I want highlight, 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 highlight. Oh, and let's label this our step 3. Step 3, we're now going to our grams or mass of our product. 1, 2, 3. 3 easy steps, not hard at all. All right, go ahead, work on problems 1, 2, 3, and 4. Look at number 1. You're going to begin with 10 grams of zinc, change it into moles of zinc, then change it into moles of zinc sulfate, and then finally change it into grams of zinc sulfate. Steps 1, 2, and 3. So we're looking at our ratios here. There's no numbers. So instead of that 2 and the 4, we've got a 1 and a 1. Okay, so that's step 2. All we're doing is multiplying by 1, dividing by 1, because our ratios for every 1 and 1 of these, we make 1 of those and 1 of these. Fun times.